Hello everyone, welcome back to the course Vector Calculus and Complex Analysis. Myself, Dr. N.CH.Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today, I am going to discuss some problems on bilinear transformation. So, this is the first part and remaining parts will be discussed in the coming sessions. Now today I am going to discuss about a bilinear transformation and the property called componendo and dividendo and some problems on bilinear transformation. First of all, what is a bilinear transformation? So this was discussed in the previous video. Here you consider this transformation W equal to AZ plus B by CZ plus D, where A, B, C and D are complex constants. And this transformation W equal to AZ plus B by CZ plus D is called bilinear transformation if the condition AD minus BC is not equal to 0. And also we have discussed in the previous session that a bilinear transformation preserves cross ratio property of 4 points. Now what is that cross ratio property? If we have 4 points T1, T2, T3 and T4, then the cross ratio property is given by T1 minus T2 into T3 minus T4 by T1 minus T4, T3 minus T2. Simply here we follow the order 1, 2, 3, 4 in the numerator and now interchange 2 and 4 elements. So 1, 4, 3, 2. So 1, 2, 3, 4, 1, 4, 3, 2. So if we have two combinations, for example, Z, there are 4 points for Z and 4 points for W. Then for these 4, the cross ratio of these two will be the same. So these points are discussed in the previous session. Now today I am going to solve some problems on bilinear transformation. That means if the points are given, how to find the bilinear transformation. For that sometimes we use componendo and dividendo property. Now what is that property? Componendo and dividendo is a mathematical technique used to simplify ratios and proportions. So if we have some ratio, to simplify that we can use this property componendo and dividendo. It's a way to manipulate ratios by adding or subtracting the numerator and denominator, which can help in solving equations and calculations involving fractions. So here we add or subtract the values of the numerator and denominator. Now what is the property componendo? For example, if we have this ratio A by B equal to C by D, then the ratios A plus B by B and C plus D by D will be the same. So if A by B equal to C by D, simply add these two, A plus B, divide by B, which is equal to adding C and D and dividing by D. Now what is dividendo? Again the same, A by B equal to C by D, now minus, subtracting. A minus B by B is C minus D by D. This property is called dividendo. Now combining these two, the componendo and dividendo property is given by, for example, we have a ratio A by B equal to C by D. Then add numerator and denominator and write in the numerator. Then subtract denominator from numerator. So A plus B by A minus B is equal to C plus D by C minus D. So this property is called componendo and dividendo. As in dealing with the points to find the bilinear transformation, we use the cross ratio property, and hence this componendo and dividendo property will help us to simplify that ratio. Now coming to the first problem, find the bilinear transformation which maps the points 1 I minus 1 onto the points I 0 minus I. So coming to the solution part, so given Z values are the points for Z 1, I minus 1. So I will take the W values also given. So W values are I, 0, minus I. Now, to use the cross ratio property, we should have 4 points. So that's why I'll consider the fourth point of Z as Z and fourth point of W as W itself. So these are the 4 points of Z and these are the 4 points of W. Now using the cross ratio property, here we need to find the bilinear transformation, and we know that the bilinear transformation preserves the cross ratio property, hence we are using that. Now what is that property? Just now we discussed 1, 2, 3, 4 divided by 1, 4, 3, 2. So first minus second, 1 minus I, then third minus fourth, minus 1 minus Z divided by, now just replace second and fourth points. So 1 minus Z, first one minus last one, and minus 1 minus I, that is equal to, follow the same for W points also, I minus 0, minus I minus W, 1, 2, 3, 4. Now 1, 4, 3, 2. So I minus W minus I minus 0. Now we need to simplify this. If it is, if there is a way to simplify this, well and good. Otherwise, we can use that componendo and dividendo property. So here, by taking this minus sign common, 1 plus Z into 1 minus I with minus sign, and here also we can take minus common. So 1 minus Z into 1 plus I with minus sign. This is equal to I into, again here we can take minus common, I plus W by minus I into I minus W. So here these two gets cancelled, these two gets cancelled. And we need to find the bilinear transformation. That means a transformation in the form of W equal to, just now we discussed, AZ plus B by CZ plus D. So in that form we need to find. So here we have W in both numerator and denominator. So that's why we can use that componendo and dividendo property, or else if there is any other way to simplify that, well and good. Now here this is I plus W by I minus W is equal to 1 plus Z into 1 minus I by 1 minus Z into 1 plus I. Now using the componendo and dividendo property, so what is that property? If A by B equal to C by D, then we can use the ratios A plus B by A minus B equal to C plus D by C minus D. So I plus W plus I minus W divided by I plus W minus I plus W. I plus W minus I plus W. The same thing here, 1 plus Z into 1 minus I plus the denominator 1 minus Z into 1 plus I divided by 1 plus Z into 1 minus I into 1 minus this, here we have minus 1 minus Z into 1 plus I. So here in numerator W gets cancelled, in denominator I gets cancelled. So 2I by 2W is equal to, now we need to simplify the numerator and denominator. So here by multiplying 1 plus Z minus I minus IZ plus 1 minus Z plus I minus IZ divided by, the same thing here in denominator, 1 plus Z minus I minus IZ, now minus sign, 1 into 1 plus I, so minus 1 minus I, then minus minus plus Z plus IZ. So here in numerator plus Z minus Z cancel, then in denominator plus IZ minus IZ plus 1 minus 1 cancel, and here minus I plus I cancel. So we get, and 2 gets cancelled. So we get I by W equal to Now what else remaining here? 2 minus 2iz by, in denominator, 2z minus 2i. 2z minus 2i. So that implies w equal to, w by I equal to 2 common here, z minus 2i, z minus I, and 2 common, 1 minus iz. So w equal to, this I goes here, I into z minus I by 1 minus iz. So w is iz minus I square by minus iz plus 1. So w is iz minus 1 by 1 minus iz. So here we get plus 1. I square is minus 1. So we get plus 1. Iz plus 1 by 1 minus iz. So this is the bilinear transformation of the given points. So using the cross ratio property and componendo and dividendo property if necessary, so we can find this bilinear transformation. Similarly, let us consider another problem. So here the points, z points are given minus 1, I, 1. So I will consider the last point as z, and w points are 0, I, infinity, and w. And there is another property that we discussed in the previous session, that if any ratio involves the infinity term, then we consider the quotient is equal to 1. The quotient or the ratio of numerator and denominator is equal to 1. So here infinite point is given. Now let us use the cross ratio property. So using that, here there are 4 points. So first one minus second, third minus fourth by minus 1 minus z, 1 minus I, 0 minus I, infinity minus w by 0 minus w, and infinite minus I. And now this minus 1 minus common, so 1 plus I, 1 minus z by, here also minus common, 1 minus I, 1 plus z is equal to minus I by minus w. So since this infinite minus w by infinite minus I, that is equal to 1, that tends to 1, we consider the quotient is equal to 1. So here by cancelling this sign, w by I is equal to 1 plus z into 1 minus I by 1 minus z into 1 plus I. So here we need to simplify this. That implies w equal to, w by I equal to, so here let us multiply the numerator and denominator with 1 plus I. Then 1 plus z, 1 minus I into 1 plus I by 1 minus z into 1 plus I whole square. So w by I equal to, this is 1 plus z into a plus b into a minus b. So a square minus b square, 1 minus I square by 1 minus z into 1 plus I square plus 2i, a plus b whole square formula. So w by I equal to 1 plus z into, we know that I square is minus 1. So 1 plus 1 by 1 minus z into 1 minus 1 plus 2i. So we get 2 into 1 plus z by 2i into 1 minus z. So this is w equal to 1 plus z by 1 minus z. This is the bilinear transformation of the given points. Let us discuss one more problem. So here find the bilinear transformation that maps the points infinite I0 into the point 0 I infinity. So Z points infinity, I, 0 and Z, and W points are 0, I, infinity and W. So using the cross ratio property, infinity minus I, 0 minus Z by, now interchange second and fourth points. So infinity minus Z, 0 minus I is 0 minus I, infinite minus W, 0 minus W, infinity minus I. So that implies this is minus Z by minus I is equal to minus I by minus W. Since the quotient infinity minus I, infinity minus Z equal to 1, by considering this, so here Wz equal to minus, so I square, and W equal to minus 1 by Z. This is the transformation, that bilinear transformation that maps the points infinity I0 to 0 I infinity in W plane. Similarly, find the bilinear transformation that maps the point minus 1, 0, 1 in the Z plane onto the points minus 1, minus I, 1 in the W plane. So again, the Z values are minus 1, 0, 1, Z, and W values are minus 1, minus I, 1. Now, using the cross ratio property, minus 1 minus 0, 1 minus Z by minus 1 minus Z and 1 minus 0. This is for Z values. Now, W values minus 1 minus I, 1 minus W by minus 1 minus W. So here minus 1 minus of minus I, so we get plus here. And now 1 minus 1 minus W, first minus fourth, now third minus second. So here we get 1 plus I. So the W points are minus 1, minus I, 1, W. So first minus second, that gives minus 1 plus I. Then third minus fourth divided by first minus fourth into third minus second. Now by simplifying this, here we get minus sign, 1 minus Z by, here minus common, 1 plus Z is equal to 1 minus W by 1 plus W with minus sign. This is minus 1 plus I by 1 plus I. So 1 minus Z by 1 plus Z equal to 1 minus W by 1 plus W. If you multiply with minus sign, so this will be 1 minus I, 1 plus I. Now we need to find W actually. So that's why I will consider 1 minus W by 1 plus W. Now send this term to LHS so that we get 1 minus Z into 1 plus I by 1 plus Z into 1 minus I. This fraction will be reversed here. So now using componendo and dividendo property, 1 minus W plus 1 plus W by 1 minus W minus 1 minus W. A plus B by A minus B is equal to C plus D by C minus D. So 1 minus Z into 1 plus I plus 1 plus Z into 1 minus I by C minus D. 1 minus Z into 1 plus I plus 1 plus Z into, here minus sign, 1 minus I. By simplifying here, minus W plus W minus 1 plus 1. So 2 by minus 2w is equal to, now we need to simplify this fraction, 1 minus z plus I minus iz plus 1 minus I plus z minus iz divided by 1 minus z denominator 1 minus z plus I minus iz minus 1 into 1 minus I. So, minus 1 plus I, next minus z plus iz. So, that implies this 2 gets cancelled, minus 1 by w equal to, so here plus z minus z minus I plus I. Now what else? 2 minus 2iz by, in denominator minus iz plus iz cancel, plus 1 minus 1 cancel, so 2I minus 2z. So this is the advantage of using the property componendo and dividendo. The ratio will be simplified. Now we need w actually. So let us rewrite this expression, minus 1 by w equal to 2 common, 2 into 1 minus iz by 2 into I minus z. So minus w equal to I minus z by 1 minus iz. So w equal to, this minus sign goes this side. So z minus I by minus iz plus 1. This is the transformation, bilinear transformation that transforms the points in z plane to the points in w plane. So in today's session, we have solved some problems on bilinear transformation. That means if the points in z plane which are converted into w plane, if the points are given, then how to find the bilinear transformation? That is discussed in today's video. Now, first one should know what is a bilinear transformation, which is in the form of az plus b by cz plus d with the condition ad minus bc is not equal to 0. And there is another important point, that the bilinear transformation preserves cross ratio property. So, in evaluating the bilinear transformation that transforms the points of z to points of w, we use that cross ratio property. In that, to simplify the ratios, again we use the componendo and dividendo property if necessary. In the next session, again I am going to continue the same. We will discuss some more problems on bilinear transformation and how the transformation transforms one figure to in z plane to another figure in w plane. That will be discussed in the next session. Thank you very much.